Umi lagi telepon.
Assalamualaikum warahmatullahi wabarakatuh. Today, we will explain about Newton law experiment. The first slide we will explain by Annisa Fauziah. Come on, Annisa.
Thank you, Balqis. Our topic is, the topic we will explain is related to the application of Newton law. What is your project? Designing a water rocket. We built a water rocket from recycled bottle.
Okay, thank you, Annisa. The next slide we will explain by Dicky Azi N. Come on, Dicky.
All right, thank you very much. So, what is the relationship between your project and the topic? So, as the first, we announced that we are actually doing a Newton's law experiment. But what is the relation between Newton's law and a rocket? So there is three reasons here. It's according to the first law of the Newton's law. So a rocket will remain on the law in speed until an unbalanced force is exerted, propelling the rocket upward. So the first law is state that the moment of inertia, and it's applied in the air rocket. And the second law, the amount of force depends upon how much air is pumped inside the rocket. You can increase the force further by adding a small amount of water, which increase the mass expelled by the air pressure in the rocket. So according to the second law of Newton's, that has the formula of force equals to mass times acceleration. So it's applied too in the air rocket. And for the third law here, the action force of the air and the water as it's rushed out of the nozzle creates an equal and opposite reaction force propelling the rocket upward. And this is the third law of Newton's, that the formula is delta F actions equals to negative delta F reaction. And then, as with a balloon, so a rocket has a similarities with a balloon. Air pressure air pressurizes the bottle rocket. Adding a small amount of water to the bottle increases the action force. The water expels from the bottle before the air does, so turning the bottle rocket into a bigger version of a water rocket toy. That's it.
Okay, thank you, Dicky. Next, we will explain by Kuni.
Okay, thank you, Balqis. So the material and tools we need to design the rocket is bottles, two uh, uh, for bottles, and duplex, uhu glue, and play-dohs. And the tools is scissor, cutter, plural, period, and ball pen. And I will show you the video. We from the video we have a problem. The direction is thrown on left, right, and the weakness of the first project is A, unbalanced fins, B, there is no empacing, C, lack of the pressure applied, D, lack of water weight given.
Okay, the next we will explain by Dicky, and I will show you the the video about PVC rocket, water rocket. Okay. Come on, Dicky.
All right. So it's very hard to see where the air rocket is propelled. So I will add up something. So in the revision, the first video, the air rocket finally can propel to the upfront, not turn left like in the first project. So why do the rocket is propelled upward, not turned left or turned right? Because here we got some revision. There is four that we got to revise. The first thing first is change the position of the fins to make them more balanced. So we got that the first problem is the fins not attached properly, and then adding emphasis using Plato. So we got there in the top, in the most top of the air rocket, there is a Plato. Why do we put it there? It's need to become the emphasis. It's need to increase the mass of the air rocket. It's need to propel the air rocket further, and then increasing the amount of weight of water used. So we are lacking of water there, so we add more water for the revised one. And then the last is increasing pressure. So in the end, in the last final video, we got our rocket propelled in a parallel. And that's how a rocket that we want to be. So it can be called we are success in the phase one. That's all.
Okay, thank you, Dicky. That's all from Group 6. Thank you very much, everyone. Bye-bye.